Welcome to our discussion on bridging EJB components with local interfaces. Local interfaces in Java provide a powerful mechanism for communication between Enterprise JavaBeans, or EJB, components within the same Java virtual machine, known as JVM. They act as contracts, defining the methods that one EJB component can invoke on another. This direct communication within the same JVM is crucial for building efficient and modular enterprise applications. Unlike remote interfaces, which involve communication across different JVMs, local interfaces are designed for interactions within the same application server. This fundamental difference leads to significant performance advantages, as local calls avoid the overhead of network communication and serialization. By leveraging local interfaces, developers can create tightly coupled EJB components that interact seamlessly. This approach promotes code reuse, simplifies application design, and enhances overall performance. The use of local interfaces aligns with the principles of modularity and encapsulation, enabling developers to build robust and maintainable enterprise applications. Let's explore the essence of local interfaces. Local interfaces facilitate direct communication between EJB components residing within the same JVM. This in-process communication eliminates the need for network calls, serialization, or other overheads associated with remote communication. When an EJB component invokes a method on a local interface of another EJB component, the call is handled directly within the JVM. This results in significantly faster execution times compared to remote calls. In-process communication is particularly beneficial in scenarios where EJB components interact frequently, as it minimizes latency and optimizes performance. The use of local interfaces for in-process communication simplifies application development. Developers can focus on implementing business logic without worrying about the complexities of remote communication protocols. This streamlined approach enhances productivity and reduces the risk of errors. Now, let's discuss encapsulation of business logic, a key advantage. Local interfaces play a crucial role in encapsulating business logic within EJB components. By defining specific methods that can be accessed by other components, local interfaces create a clear separation of concerns. This encapsulation ensures that the internal workings of an EJB component are hidden from external entities. Other components can interact with the EJB component only through the defined methods in the local interface. This controlled access mechanism promotes code modularity and reduces dependencies between components. Encapsulation of business logic using local interfaces enhances code maintainability and extensibility. Changes to the internal implementation of an EJB component can be made without affecting other components, as long as the local interface remains unchanged. This flexibility is essential for evolving enterprise applications over time. Lastly, let's look at performance optimization local interfaces for efficient interactions. Local interfaces are instrumental in optimizing the performance of enterprise applications. Their ability to facilitate in-process communication eliminates the overhead associated with remote calls, resulting in faster execution times. When EJB components communicate through local interfaces, the JVM handles the interaction directly. This avoids the need for serialization, network communication, and other time-consuming processes involved in remote calls. As a result, local calls are significantly faster and more efficient. The performance benefits of local interfaces are particularly pronounced in applications with frequent interactions between EJB components. By minimizing latency and maximizing efficiency, local interfaces contribute to a responsive and seamless user experience. Consider a stateless session bean designed to perform basic arithmetic calculations. This calculator bean exposes a local interface with methods for addition, subtraction, multiplication, and division. Other EJB components within the same JVM can utilize this calculator bean by invoking its methods through the local interface. For instance, an order processing component might need to calculate the total price of an order. This component can leverage the calculator bean's local interface to perform the addition of individual item prices, resulting in a fast and efficient calculation. This real-world example highlights how local interfaces simplify interactions between EJB components. The calculator bean encapsulates its logic behind the local interface, providing a clear and efficient way for other components to utilize its functionality. Section 6. Local versus remote interfaces. Choosing the right approach. The choice between local and remote interfaces depends on the specific requirements of the application. Local interfaces are ideal for communication between EJB components within the same JVM, offering performance benefits and simplified development. Remote interfaces, on the other hand, are necessary when EJB components reside in different JVMs, potentially on different physical servers. While remote interfaces provide flexibility for distributed applications, they introduce overhead due to network communication and serialization. The decision to use local or remote interfaces involves a trade-off between performance and distributability. Local interfaces prioritize efficiency for interactions within the same JVM, while remote interfaces enable communication across distributed environments. Section 7. Advantages of local interfaces. A summary. Local interfaces offer several advantages for enterprise Java development. Enhanced performance in-process communication eliminates the overhead of remote calls, resulting in faster execution times. Simplified development. Developers can focus on business logic without the complexities of remote communication protocols. Code modularity. Encapsulation of business logic behind local interfaces promotes code reusability and maintainability. Reduced dependencies. Controlled access through local interfaces minimizes dependencies between EJB components. Improved scalability. Local interfaces facilitate efficient interactions within the same JVM, contributing to application scalability. Section 8. Conclusion. Local interfaces, a cornerstone of enterprise Java efficiency. Local interfaces play a vital role in enterprise Java development, providing a powerful mechanism for efficient and modular communication between EJB components within the same JVM. Their ability to facilitate in-process interactions, encapsulate business logic, and optimize performance makes them an indispensable tool for building robust and scalable enterprise applications. By leveraging local interfaces, developers can create tightly coupled EJB components that interact seamlessly, leading to enhanced productivity, reduced development time, and improved application performance. The use of local interfaces aligns with the principles of modularity, encapsulation, and efficiency, making them a cornerstone of effective enterprise Java development. Section 9. References. Fowler, Martin. Addison Wesley Professional, 2002.